Yes, I left by saying that there is a difference between electron configuration diagram and there is electron configuration. So you realize that we have the word diagram and we have the word just configuration. Now, if any case in an examination, you are asked to draw or rather show the structure, they can use the word structure or rather they use the word diagram. Now, in that case, you are to draw. You are to draw, beginning from the nucleus, the first energy level, the first energy level, the second energy level, the third, and so on. So remember, you're going to draw. We're going to draw. So that is what we refer to as diagram, or rather what? Structures. Now, we want to see how we can draw the diagrams and how we can as well write the electron configuration. Yes, how to draw and how to write the electron configuration. And before that, there are rules. Rules followed when writing and drawing the electron configuration, or we can talk about diagram. Yes, there are some rules followed when we want to write the electron configuration or we want to draw the electron configuration. Now, as a science student who is ready and preparing for KJSF, this electron configuration arrangement, it won't miss. And I'm telling you for free that this will come in your exam. Because a good paper, a well-set paper for science must have electron configuration, either arrangement or rather diagram, or rather a question pertaining the electrons. Now, there are some rules. And number one rule, we know that electron distribution or electron arrangement of electron arrangement, within the nucleus, not the nucleus, but within the energy level, electron arrangement within the energy level are as follows. That is number one rule, are as follows. That the first energy level, must hold a maximum of 2 electrons. That is the first rule. It says that electron arrangement within the energy level, the first energy level, must hold a maximum of how many electrons? 2. Must hold a maximum of 2 electrons. Now, if I draw a model the way I drew it, and the first energy level follows. So this is the nucleus, the central part of an atom. Now it means that the first energy level must hold how many electrons? 2, as you can see. That is the first rule. The second rule states that the second energy level holds a maximum of 8 electrons, depending on the available number of electrons, that particular atom has, or rather element has. So you realize that the second energy level holds a maximum of what? 8 electrons, depending on the available number of electrons a particular atom has. Now you realize that there are some atoms, let's say for instance, boron. Boron is number 5 in the periodic table. Boron is number 5 in the periodic table. Now, if we want to distribute the electrons, if we want to arrange the electrons, this is how we are going to arrange. We have said that the central part of an atom, the nucleus, must be present with boron there, and then followed by the first energy level having 2 electrons. Having how many electrons? 2, because the first rule says that the first energy level must hold a maximum of 2 electrons, and you can see the representation. So when we want to represent the electrons of boron within the energy level, or within the energy levels, the first energy level must hold a maximum of 2 electrons. And then we follow, remember the electronic configuration should be 2 to 3. Why am I saying 2 to 3? We said that the first must hold 2. So the first has 2. Good. So the first has how many? 2. That is the 2 electrons. Now this is electron configuration or electron arrangement. But this, by showing through a diagram, is what we call electron configuration diagram. Now the first must hold 2. That is the first rule. And the second says the second energy level holds a maximum of 8 electrons. But depending on the available number of electrons that particular atom has. Depending on the available number of electrons that particular atom has. So you realize that boron has how many? Only 3 available electrons it has. So it means as we're going to draw the second energy level, it will have only 3. 2 and then 3. So we have how many in the second energy level? 1, 2, 3. So that is the electron arrangement of boron. The electron arrangement of what? Of boron. So it is 2 to 3. So we are beginning. The first energy level holds 2. And then what remains? We have 3 electrons because it is number 5. So 2 plus 3 is 5. The first energy level has 2. And then followed by the second energy level holding only 3. Remember, it can accommodate. It can accommodate 8 electrons. So instead of saying holds, we can say it accommodates a maximum of 8 electrons. That is how other book says it. But they mean the same thing. No worries about that. Now we have known that the second only accommodates how many? 8 number of electrons. But depending on the available number of electrons that particular atom has. Let us consider the second one, sodium. Let us see how many energy levels do sodium has? How many number of electrons do sodium has? And as well, how can we distribute these electrons? Good. So we are there. We are there. I hope we are moving together. We are sailing within the same boat. So number 2 is sodium. Let us see. So first of all, I told you we have to draw the central part of an atom, the nucleus. We know that the symbol for sodium is Na. Now, the first energy level, the rule says, must hold only 2 electrons. I hope you are with me. So 2, it can accommodate only how many number of electrons? 2. And because sodium is number 11, sodium is number 11. Now, the first holds 2. And then the second, I said, holds a maximum of 8. So 2 plus 8 is what? 10. What remains is 1. What remains is 1. So we are coming there. So if we want to draw the diagram, the first holds 2. How about the second? And because sodium has 11, so depending on the available number of electrons that particular atom has, the rule says we are restricted to 8 number of electrons. Now, it means the second will have 8. 2, 3, 4, 5, 6, and lastly 7, 8. Wow. Look how it is well arranged. The electrons have been arranged. The first energy level, rule says it can accommodate 2. The second energy level, rule says it can only accommodate 8. Only accommodate. And it must. It must. Depending on the available number of electrons that particular atom has. Now, because sodium has 11, because sodium has 11, you can see, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What remains is 1 because sodium is number 11. So it means we have to draw another energy level somewhere. And we put that our 1. Now this brings me to the third rule. The third rule. And the third rule says, the third energy level can only accommodate can only accommodate 8 number of electrons that is maximum it can hold depending on the available number of electrons. On the available number of electrons that particular atom has. Depending on the available number of electrons that particular atom has. That is what the statement is saying. The third rule. I hope we are together. Now, it is a very interesting class because we are learning new concepts. We are learning new things. Remember, we have said the first holds 2. The second must accommodate a maximum of 8 electrons. And again, we are repeating that the third energy level can only accommodate 8 number of electrons maximally, depending on the available number of electrons that particular atom has. Now, if it is, let's say sodium, we have seen that sodium is 281. This is what we call electron configuration. Not diagram. I'm repeating. 281 is electron configuration. Why say so? Because the rule says that the first energy level, which is this one, can only accommodate 2 electrons maximally. The second rule says the second energy level can again accommodate 8 number of electrons, but depending on the available number of electrons that particular atom has. And if you want to know the available number of electrons a particular atom has, I told you, check the number of that particular atom. If, for instance, it is sodium in the periodic table, we know that sodium is number 11. So sodium will have electron configuration of 281 because 2 plus 8 is 10. And then what remains is only 1, bringing it to 11. So we have seen the third rule, which when we placed 1 here, it can accommodate 8. But because sodium is number 11, it can only accommodate 1 at that point. Now let us consider an example of an atom or element having electrons up to the third energy level. Now let us see an example by the name calcium. We know that calcium in symbol is capital C, small a. And it is number 20 in the periodic table. And remember, in junior secondary, I told you that we are only going to learn up to 20 elements. Unless otherwise, when we have examples of metals, other metals that are essential and you need to know them. So we'll know them just by names and symbols, and we'll also know them by their uses. But rather we'll not know them where they fall under periodic table. Now, calcium is number 20. Electronic configuration will be, I said the first 2, the second 8, 2 plus 8, 10. We still have 10 more. The third was 8. So what remain is 2. What remain is 2. So we have 2882. This is the electron configuration. Electron configuration. Electron what? Configuration. Let us see the electron configuration diagram, or rather the structure. So we'll come, draw the nucleus, that is for calcium as an element, Ca. And then the first energy level can only accommodate 2 electrons. The second energy level can accommodate 8 electrons. That is what the rule number 2 says. That is what the rule number 2 says. 1, 2, 3, 4, 5, 6. Lastly, 7, 8. Good. So that is the second energy level, accommodating only 8 electrons. So we have remained with 8 too. So we go to the third energy level with 8. 1, 2, 3, 4, 5, 6, and lastly 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We are not there. We are not at 20. So what are we doing? We bring another energy level. We add another energy level. We add another energy level. How many electrons are remaining? 2. 2. So this is the electron configuration diagram for calcium. Electron configuration diagram for calcium. Good. Now, we have seen the first rule, the second rule, and the third rule. There is the fourth rule. There is the fourth rule. Now, the fourth rule says, We can write, sorry, so this should be C, and then lastly D. The fourth rule says that the fourth energy level can accommodate a maximum of 18 electrons. So it says the fourth energy level, can accommodate a maximum of 18 electrons. Can accommodate a maximum of 18 electrons depending on the available number of electrons that particular atom has. So that is the fourth rule. But remember, up to your level, you will only be able to understand the electron configuration diagram up to the third rule, which we talked about, up to the third rule. And now the last rule. Just know that the energy level, the fourth energy level, can accommodate a maximum of what? 18. But now the last rule says that the first energy level must be first filled with electrons before moving to the next energy level. So that is what we have as the last rule, that the first energy level must first of all be filled with electrons before we move to the next energy level. So before we move to the second energy level, as in this case, before we move here, we must first of all fill the first energy level. So you saw me filling the first energy level with only 2 electrons. So that is the rule. And the rule stands that the first energy level must occupy or accommodate 2 electrons. After that, after it is filled, we can now move to the next energy level. And that is the second energy level. And we have said it can only accommodate 8 number of electrons. Once it has accommodated and that particular atom has more electrons, the available number of electrons are more, so we can proceed to the third. And when that happens and it is filled, we now proceed to the fourth, and so on and so on. Good. Now this is what we call electron configuration diagram and electron configuration. When we are told to draw the electron configuration, as in this case of calcium, the electron configuration here is 2882. 2882. But this is the electron configuration what? Diagram. Now, I hope the class was interesting. And if you have a question, you can ask me a question down there within the comment section. I'll be available to answer. Now, before I move to the next subtopic, I want to give you some question based on this subtopic called electron configuration and electron configuration diagram. Now, I want you to try the following. Try the following. Draw the electron configuration. Draw the electron configuration of the following elements of the following elements. So we have Roman 1, potassium. Roman 2, we have beryllium. Roman 3, we have oxygen. Roman 4, we have chlorine. Consider doing that. It is a very simple task. And if you have any challenge or any problem, kindly consider contacting me, or rather showing your interest or your worry down there at comment section. Thank you for listening. Thank you for enjoying the lesson. I hope you have enjoyed. I have also enjoyed. Welcome, and we'll do the other lesson or the other subtopic next time. Bye bye. See you. I think it's okay. It's good. It's good. It's good. Oh, ini ya sai.